A soup company needs to make a cylindrical tin that can have a capacity of 500 ml of soup. Find the dimensions of the can that will minimise the cost of production. For part A, we need to show that the surface area, A centimetres squared of the tin, is given by 2 pi r squared plus 1000 on r. So first of all, we can see that the area will be equal to 2 times the area of a circle, which is on the bottom and the top of the tin, which is 2 pi r squared. And then we have the middle of the cylinder can be unrolled to form a rectangle, and that rectangle will have a length of 2 pi r, which is the distance around the outside, and then it will have a height of h, which is this distance here. Now we need some way of finding h in terms of r, and to do that we can use the volume of the tin. So we know the volume is going to be equal to pi r squared, which is the area of the circle. If we multiply that by its height, we get the volume of a cylinder, and we know that that has to be equal to 500 mils. So solving for h, we get h is equal to 500 divided by pi r squared. So if we substitute that into our area formula, we get that the area is equal to 2 pi r squared plus 2 pi r multiplied by 500 divided by pi r squared. And if we simplify that, we get 2 pi r squared plus, and we get 1000, which is the 2 times 500. Then pi r on the top line and pi r on the bottom line cancel, just to leave r behind, which is what we were asked to show. For part B, we want to find the height and radius r corresponding to the tin with the smallest possible surface area. So what we can do is we can set our derivative a dashed of r, which is equal to 0. And now our a from before, if we derive that, we get 4 pi r minus 1000 divided by r squared, and we want to set that equal to 0. Now if we get a common denominator, we can write that as 4 pi r cubed minus 1000 divided by r squared is equal to 0. And any fraction that's equal to 0 simply implies that the top line is equal to 0, because if the bottom line equals 0, it's undefined because we can't divide by 0. So this means that we can say that 4 pi r cubed minus 1000 is equal to 0. And if we solve that fully, we get r is equal to the cube root of 1000 divided by 4 pi, which simplifies down to 5 times the cube root of 2 divided by pi. Next, we can use this result and find the height. So the height, we have our formula reproduced up here. Our height is equal to 500 divided by pi r squared. But we know that our radius for the minimum is equal to 5 times the cubed root of 2 divided by pi. So we put that in, so we have pi times 5 by the cubed root of 2 divided by pi all squared. And if we get a calculator to help out with that one, we find that the height is equal to 20 divided by the cubed root of 4 pi. Finally, we want to state the surface area of the tin so that the production cost is at a minimum. So previously we found that a dashed of r equals 0 gives r is equal to 5 times the cubed root of 2 divided by pi. And then to find the area, we simply substitute that into the formula, which is back up here. So wherever there's an r, we replace it with 5 times the cubed root of 2 divided by pi. And our answer, if we get a CAS calculator to do that for us, correct to 2 decimal places, is 348.73 centimeters squared. So that's the minimum possible area so that we keep the production costs as low as possible.